Hello, it's James from XRobots.co.uk. This is part 6 of my 3D printed R2-D2 style droid, which is in fact going to be an R6 droid, which is why I've got these orange sections on. So a bit of a recap, the whole thing is going to be 3D printed as much as possible. It's going to be a bit of a 3D printing mechanical showcase. It's going to convert from 3 legs to 2, so I've got this central carriage I built, which sucks the centre foot up, and also the shoulders are motorised so that it can turn into that classic 3-leg R2-D2 pose and move back again. So in the previous episodes I've 3D printed the entire frame, sorted out some of the mechanics and sorted out how that centre foot retracts using a piece of studding which is on a belt drive. Last time I did the legs, this whole droid's going to be quite custom, so the idea is it's never going to have skins and it's going to have little gadgets that flip out. So at the moment it looks quite hollow and like there's some pieces missing. There's going to be quite a lot of the normal details that R2-D2 has, the vents and so on, but then the rest of the panels are going to be filled up with gadgets and also electronics, so you can see how it works. So I've got an Arduino Uno here, which may sit somewhere there with some nice blue lights flashing and things like that, and also have some other logic lights so I can see what's going on when I'm controlling it. It's going to have lots and lots of functions, as well as being fully radio controlled and driving around with lights and sound. Another reason that it's quite custom is that I actually made a mistake last time with the legs. So I'm making this video before I've published the last part, which is part 5, so I don't know if anyone's noticed, but in fact I've made the legs too thin. So I would blame it on converting the plans from imperial to metric, but in fact I did that part correctly and wrote the dimensions down correctly, but actually I made them too thin. So they're not too bendy. There's some more reinforcement to go in where this booster cover is, the orange part. So I think they're going to be okay, but they are slightly thinner than they should be. There's still some the shoulder horseshoe pieces to go on, which will make them thicker. But in fact, there should be about another inch on the back of the leg, so they're quite a lot thinner. So I've stuck these on quite well now with acetone weld, so there's no way to backtrack and redo it. Eventually I'll release the CAD files, and this is one of the reasons I haven't. So if you're building this from the CAD files, you need some more layers on the back. These legs are all made of 5mm layers stuck together. So today we're going to try and sort out the motorisation of the feet, and then we can hopefully try and drive it around and properly test that 232 conversion without a skateboard. My plan for motorising the wheels in the feet is to use these motors I've already got. I've looked at brushless motors and various others, but I've decided in the end to use windscreen wiper motors because they're good workhorse motors, and basically they've got a fair amount of power in them. I'm going to be powering them from some 11.1 volt lipos. So I got hold of some batteries. They're actually second hand and I didn't pay very much for them. So I've got a number of them. They're 2 amp hour. So I've got 2 here and a couple more. I know where they came from, so I guess it's no worse than if I had used them myself when they were already used. But however, lipos can be quite dangerous because they can burst into flames and things if you're not careful. So I've actually bought a fairly decent charger, which is the turning-lee charger, which does balance charging. So you've got this little cable that plugs in the side so it can balance the voltage of all the cells, and it can discharge and condition them and so on. But they seem to be charging fine and so on. So the good thing about these wiper motors is they've got 3 wires. They've actually got 3 speeds built into them because obviously they have to wipe the windscreen of your car. So if we go between black and red, so I've put a little marker on this nut that's spinning. So you can see that I think is the slowest speed. Black and blue goes a bit faster, and if we go between red and blue, it goes faster still. However, even in the fastest speed mode, we only get about 2 revolutions a second. So even with a 100mm wheel, basically then we'll cover basically 2 feet a second, which I think equates to just over 1 mile an hour, which isn't really quick enough. So in fact what's going to happen is I'm going to take the worm drive off here. There's a worm gear driving a bigger gear inside, and we're just going to use the actual motor with a belt drive to the wheel. The only challenge with that is that this is all built into one unit. There's 2 screws that take the metal off the end, but if you do, then the top of the motor's gone. There's nothing to hold the spindle anymore. So actually what we need to do is hacksaw through this metal, and I've done this before for my boat propeller project. So I need to get my hacksaw out and start sawing through this. My plan to actually drive this is to use a V-belt, so instead of having a belt with teeth on, I'm just going to have a belt that grips with friction in this V shape. That means when it's pulled tight, it's pulled tighter into the V. So the smaller pulley there is the one that goes onto the motor, so that's going to have a captive nut in that square hole and a bolt that goes through the round hole, which then grips the shaft, and there's going to be a flat on the shaft in order to do that. The motor itself is made of these two parts, or in fact three really. So we've got another V-belt which is going to be coupled onto it, and then we've got a wheel, and the wheel is going to have a rubber tyre on. So this is going to be printed as a hybrid print, with both parts printed in one print with dual extruders on the Lulzbot TAZ with a flexi dual extruder. So one is for extruding Ninjaflex, the other one is for extruding rigid material. So we're going to print this wheel in one print. So here is a previous hybrid print, which is a very similar example. It's one of the first prints I did with dual extruders, and this is a Ninjaflex tyre which is red on an ABS hub. That was printed in one print with dual extruders, and the two materials are bonded together with heat. So the problem I've had with dual extruder prints in the past is that Ninjaflex compresses in the nozzle while it's printing, so when you switch and print with the ABS nozzle, basically it decompresses because it's very elasticy, so that causes the Ninjaflex nozzle to ooze quite a lot. And that means the pressure's gone in the nozzle, so when it comes back to print with Ninjaflex, as well as putting ooze on the print, we find that actually the first bit it prints with Ninjaflex, when it comes back to that nozzle, is missing because there's no pressure in the nozzle anymore, because it's all oozed away. So if we look very closely at this, we should be able to see, perhaps, that right round the edge here there's kind of a dodgy gap where there's not so much filament, which makes a weak spot in the print. And obviously that's okay if the part is really solid, but if you're trying to do a fine print, then you'll find that you get lots of gaps in your print. So we need to adjust the slicer settings to try and compensate for that. I'm going to do two things in Slicer which sets the settings for the actual printer. So here's my hybrid print. So we've got the hub is green when I select the hub STL, and the tyre is now green when I select the tyre STL, and each one has a series of settings. So my hub is going to print with the default extruder of 1, which is for ABS. It's going to be 40% honeycomb. The tyre is going to print with extruder 2, and it's going to be 100%. So basically what I've done here is set the infill to print much slower for the Ninjaflex. So the hub there I'm printing 100mm a second, and the tyre I'm printing at only 30. And the reason for that is that the infill is the last thing it does before it switches extruders. So it does the perimeters, then it does the infill. So that means if it slows right down before it switches extruders, then there won't be so much ooze because there's not so much pressure building up in the Ninjaflex nozzle. The other thing I'm going to do is look at the extruder settings. So these are the retraction and all the settings that are custom to each extruder. So what we've got with Ninjaflex is the retraction settings at the bottom here. So before it switches, it retracts 45mm of filament. That still isn't quite enough to stop the ooze, and if you go any further it retracts the filament right out of the extruder. So what I've put in is a 10mm extra length on restart. So some of that filament is still going to ooze away, but when it comes back to print with Ninjaflex, it goes and puts an extra 10mm down. So that should hopefully build up the pressure in the extruder again, and then it won't leave a gap when it starts printing. So that has been printing for about 2 hours 22. It's just under halfway through to make up my 30mm height. So it's doing quite well. That is currently printing ABS there. And we'll have another look when it switches filament and does the Ninjaflex. So there it is, retracting the ABS and bringing out the Ninjaflex plus a bit of extra Ninjaflex. So the Ninjaflex has oozed and got caught on the brim, isn't actually missing from the print. So unlike the previous wheel example, if we go really close in on this, if I can get it to focus, you should hopefully be able to see that there's no gaps in that print. It's actually got a really good solid amount of Ninjaflex. So that's now doing the perimeter at full speed, so it should do 4 of those. The last one is at 70% of the speed. And now it's going really slow to do the infill, so down to a third of the previous speed, which means it's building up much less pressure in that nozzle, which is reducing the ooze. There is quite a bit, but that's from the whole print. It hardly oozes when it finishes that layer, which is quite good. So that is retracting Ninjaflex and bringing back the ABS, and you should be able to see, if you keep your eye on that nozzle, there's a tiny bit of orange ooze on it that gets wiped off. But actually it's really not that much, and eventually obviously it only uses so much, so we get a little bit, some of it gets wiped on the prints, but that's greatly reduced the ooze, going slowly on the infill before switching nozzles. Here are my parts. So this is the original hybrid print and this is the new one. Hopefully you can see that's much better quality. There are no gaps there. It's looking pretty good, like solid Ninjaflex. I haven't got this dodgy weak spot basically, and everything's perfectly aligned. I also made it a kind of zigzaggy pattern around here. One, because it looks quite Star Wars, and two, so if the tyre does become detached it doesn't slip at all. So that piece is then bonded onto this pulley, which is the other V pulley, and I've left these 3mm holes which I'm going to basically jam pieces of steel in so that it doesn't slip, but it will be acetone welded together. And this is my other V pulley for the motor, and you'll notice I've got that captive nut in there and a little grub screw, which is an M5 grub screw screwed in, which is actually a piece of M5 studding with a slot cut in it with a hacksaw, so that's nice and flush, and that will be able to grip the motor shaft. I've cut the end off my motor now, as you can see. These are some of the bits that are inside, and also this is a piece of metal which is covered in metal filings and grease, so hence it's in a bag. But now we've got obviously the main output shaft of the motor. If we just connect that up to a battery, that's in between the red and black wires, so that's the slowest mode, but it's also the highest torque. So it goes pretty quick. What you might be able to see there, let's just try and zoom in, is I filed a flat onto that side of the motor there. So that was originally a worm gear, which is actually part of the shaft and can't be removed. So I filed that flat on there so that I can then attach my gear with its captive nut, and that should, or my pulley, so that should just do up right onto there. And that should sit on there nice and tight. I've now got my pulley attached to the other wheel with the rubber tyre, so that's acetone welded in. You can maybe just see I've basically hammered some 3mm steel rod in there, which is basically this stuff. It's just been hammered into the holes to hold them so these don't rotate against each other, and they've also acetone welded together. I've also brushed acetone over both pulleys to make them smooth, which will help stick them together and make them smooth and hopefully more grippy, possibly. So the belts themselves are 3D printed in Ninjaflex again. So basically these are V belts. I started with a really big V shaped belt. It sits nicely in the V. This was the first attempt, but it's actually really stiff, so there's no chance at all of tensioning this around the motor. It's far too big and not bendy enough. So then I tried a much smaller one, so that again is a V shape. I don't know if you can just see that. It fits quite nicely into the V. That's a lot more flexible. It's a bit big though, so I've basically made this smaller one, and that will fit quite nicely between the two items to make that drive mechanism. It's got some stretch in it, but not that much. I can make it less stretchy, of course, by scaling it up. So I could either make it thicker back to front, and in fact it doesn't occupy the full V, so it could be wider. Obviously if it's made deeper, then it will be less stretch, or less likely to go around tight corners, and if it's wider it will just be less stretchy and have more grip, because there'll be more friction. So I'm going to start with this one, and we'll see how it goes. The next part, of course, is to mount this on something, so I've designed a foot for them to be mounted on, which has the motor and the pulley there. So what I've done is taken the pulleys and the motor I've actually drawn in CAD so I can basically size the size of the foot, and make sure it's the right size. So we don't actually need to obviously print those parts again, and we don't need to print the motor. Similarly, the caster on the back here, which is shown in a kind of brown and green, is another metal part. Of course it swivels round, so I've drawn that twice back to back so I can check there's enough clearance when it does so, and enough clearance to get through the gap at each side. So what we've got here are, again as usual, two 5mm layers laid together, which will be printed in ABS and chemically welded together. So if we take away this green layer, there's a blue layer. If we take away that, you can see inside. There's various things at the top here to hold the leg, and also you'll notice two square cutouts there which are to hold bars which support the parallel rods to hold the foot parallel. So we'll look at those once it's printed. There's also screw holes on the bottom of those to hold the right angle brackets in, which I'm going to make out of metal. Apart from that, it's fairly basic. It's a fairly easy belt drive mechanism. Got the motor mounted there so the pulleys are parallel with each other so the belt doesn't come off. And we've got various other blocks with wedges on so that we can keep those things really rigid. So of course this isn't actually the shape of R2-D2's foot, it's also tapered at the sides, and on one side is what's called the battery box, which in this case will actually contain the batteries and motor controller. So those aren't shown here, those will be additional frame parts which are added on after that. This is just basically the main drive mechanism. As usual, all the parts are printed out and laid flat. We've got both feet there, so we've got an opposite set of parts as well. They're all laid flat on the bed so that those can be printed out, and then we'll assemble all the parts. So all the parts are printed and I've assembled one of these. The two 5mm layers are these, which are acetone welded together, as with all the other parts. The blocks are acetone welded onto one side, but not the other side. So this entire side will come off. There are some screws in here as well that hold these other wedges, like the mount here. And again, that caster mount is acetone welded and screwed on one side, but only screwed on the other side so I can get this off. And the reason is for that is so that I can change the drive belt, which is sitting just in there. That seems to be about the right tension though. If I grab the motor pulley, I can just slip this if I really try. So I can, as I say, make a tighter tension belt. There's no adjuster in this to actually tension the belt. Sometimes you see in these feet there's a slider so the wheel can be winched away to tighten the belt, but since I can make custom belts any size, I haven't bothered doing that. So the caster just fits in there. Everything looks pretty good. We've got the mount there for the leg, which we'll come onto shortly. But basically this whole thing's pretty sturdy. I've also got space there for another 8mm bolt, which could hold those parallel if it wanted, but it's pretty tough without it, so I haven't bothered to put it in. The rest of it's bolted through with 6 and 8mm bolts and nuts on the other side. So let's give it some power. I've put bullet connectors on the red and black wire on the motor, which sticks through that handy hole. I've ignored the blue wire for now. So the red and black is the slowest motor mode natively, but also the highest torque. So let's just stick a LiPo on. So it's going pretty quick, and there's quite a bit of torque there. The thing is going to be on casters ultimately, so that's going to be more than enough to get it rolling. And that's top speed. Obviously I'm going to have another motor controller which will actually be able to slow that down using PWM for whatever radio control system that I have. And then there were two, so now I've printed out two sets, making sure of course these are opposites. And just a quick note is that the actual battery box on the side of the foot is where the motor goes. So even though they stick out, they're actually covered by another piece if you have a look at some pictures of an R2-D2. So let's talk about motor controllers. So I've got some motor controllers, one for each motor, which is one of these, which I got from eBay. They came from China. They do up to 12 volts, and these are meant for radio control cars, so they have forward and reverse and braking functions. And for now I'm going to be controlling this with a normal radio control transmitter and receiver, and this is a 6-channel set. I'm going to talk some more about the electronics in later episodes, but that's more than enough to control R2-D2. This was £23 delivered. and it was shipped from within the UK. It's made by Fly Sky, which apparently is quite a well-known make. There's a few YouTube reviews. So normally you plug radio controlled servos into the receiver. The motor controller's got the same type of plug, and basically you plug your battery in and the motor, and it controls the motor forward and reverse on one of the sticks or whichever channel you plug it into. So that's great. We can plug in 2 of those, one for each motor, and then we can go driving around. So let's try and give that a bit of a test. So some super high-tech testing. Obviously the Droid only has 2 legs and I haven't sorted out the mechanisms that keep the feet parallel, and I really wouldn't want to drive that much in 2-leg mode anyway. So I've just rigged this up with a bit of wood so the feet are next to each other, and I've got the batteries on the back. The battery charger box there on top is just to apply some extra weight over the driven wheels, because without the weight of the Droid on top they slip on this smooth floor. So we're all set up for control, so let's have a go. It's going to be pretty fast. The main issue I was having driving there was I've got no servo mixing, so basically one wheel goes forwards when I push the stick forwards, the other one's on another channel, so when I push the stick this way, that one goes forwards, and I was going to put it on this stick so you drive like a tank, but this one's got no spring on it for the throttle on a helicopter, so you can set it and leave it, which is quite dangerous because if someone nudges the controller it will just carry on going, whereas this one at least springs back. So in fact I put it on this channel, which also has a spring. So I had to push the stick kind of diagonally to drive forwards and the other way to drive backwards. So that'll be rectified in the future, but for now it's really hard to drive in a straight line. This is what it's going to look like with its feet on. Obviously I still need to make the centre foot, but it's looking okay. The scale is potentially a bit weird, so it looks like its legs are quite long and skinny, and that is because of the missing battery boxes that I keep talking about. So when I'm talking about battery boxes, I'm talking about these things, which make it have thicker ankles and it looks a bit better proportions. So obviously mine doesn't have those, so its legs look a bit skinny, but in reality it's just the missing pieces. That is the end of another R2-D2 episode. Next time hopefully I'm going to get that centre foot on with the other wheels, so hopefully we'll be able to actually drive this Droid around of a fashion after that. So don't forget to subscribe to my channel and check out my other videos. Also don't forget to check out my Patreon campaign at patreon.com/XRobots, where you can get access to some exclusive rewards, including a live broadcast with me and some exclusive live project content that you can interact with live.